All right, so again, we have to decide, do we have logs on both sides, or is the log equal to number? And here we set a log equal to a number. So looking at the left side, I have the log of 5x. That is one single log. I don't have to bring anything together. So the second step is to take it to exponential. Here's my question. Where's the base? It's not written, is it? What is it if it's not written? 10. Okay, so remember that. We're going to take it to exponential. So it is going to be, maybe, 10 to the third power equals that entire argument. 10 to the third equals the whole thing in parentheses, the 5x. So we didn't have to simplify because it was already one single log. Then we have to get it out of log form by taking it to exponential. And then depending on what you have, you're going to have some sort of equation to solve. If your variable is in the argument, which in these most of the times it will be, you're just going to simplify any numbers and then solve the remaining equation. So that's our final step for these, is to simplify and solve. What would I need to simplify here before I could solve? 10 to the third power. What is 10 to the third power? 1,000. Okay. And then I need to solve that for x, and I can do that by dividing both sides by 5. Yep. And so x is going to equal, what is that, 200? The only thing we have to remember is when we are solving these, our variable is in the argument. My argument cannot ever end up being a negative number. That doesn't mean that I can't get a negative for x. It just means if I go back and look at my argument and I plug that x value in, if I plug in 200 here, is 5 times 200 positive or negative? It's positive, right? If it turned out negative, then I would not be able to use x equals 200, but since it turns out positive, I can keep that as an answer. And we will get to some in a few minutes that you will have to be careful with. Does that make a little bit of sense? Okay. All right, number 2. I have a log equal to a number. So we're going to follow the same steps. First of all, see if there are any logs that need to be combined. Any logs that need to be combined on this one? No. Okay. So then we're going to take it to exponential. What I have to do next is take that equation to exponential. Once you get it to exponential, then you're going to simplify any numbers that you need to simplify, specifically numbers raised to a power, and then solve the remaining equation. So again, we're taking it to exponential. 2 to the third power is going to equal everything inside that parentheses. So it's going to equal the entire 3x minus 1. That's my whole argument. I would like to simplify 2 to the third, which is how much? 8. And then I can solve the remaining equation for x. Add my 1 over. That is 9 equals 3x. And I can divide by 3. And so x is going to equal 3. The one thing we have to check is plug it back into that argument. Does 3 times 3 minus 1 stay positive or turn negative? Stays positive. So x equals 3 is a good answer. Okay. Not really much different than what we've been doing so far, right? Okay. Ooh. I want you to try 3, but I'll go ahead and tell you So you're going to have to deal with some fractions. And we're looking to see, do we have logs equal to numbers or logs equal to logs? Then you're going to combine any logs that need to be combined if they do. Sometimes they do, sometimes they don't. Remember, calculators are your friend if you're not good with fractions. We've learned how to do these in the calculator before. First question, do I have any logs that need to be combined before I try to start solving this thing? No. Okay, so we're going to take it straight to exponential because it is a log equal to a number. So that's going to be 4 to the negative 2 equals all of that stuff. First question, 4 to the negative 2. What is that as a fraction? 1/16. Okay. All right. Again, if you're not comfortable with fractions, let the calculator do your work. I want to start trying to solve this for x. What do I have to get rid of first? 5. So we're going to subtract the 5. So in my calculator, or you can do it the old-fashioned way, I'm going to do 1/16 minus 5. And if I do that in the calculator, it gives me something that looks like this. Okay, but that's a mixed number. We don't want to deal with mixed numbers. We want to go ahead and get it into an improper. So in order to do that, once I have that in my screen, is I just hit the second key and my fraction key again, and I hit equals, and that changes that into negative 79/16. Okay, again, I just did that in the calculator. I did 1/16 minus 5, and then I changed it back to an improper fraction. And then how do I solve for x? I have to divide by negative 2. Again, I'm going to let the calculator do my work for me. I'm going to divide it by negative 2. And that gives me a positive 79/32. You have a calculator? You need one? Yeah, that won't work with fractions. Yeah. All right, so to hit the 1/16, I hit 1. 16 minus 5. And what is that? That's a mixed number. So in order to derive a mixed number, you hit second and your fraction key again. And then we just divide it. All right, now here's the thing. We have to check to see if this is a valid answer. So I need to go back to my argument, which was what, 5 minus 2x? But what I want to do is I want to replace that x with 79/32. I need to see if that is a positive number or a negative number. So here's what I'm going to do. I'm going to leave my 5 for now. I'm going to multiply that fraction, 79 over 32, times 2. It gives me a mixed number, so I'm going to change that again. That gives me 79 over 16. And then I just need to see, is that going to be a positive result or a negative result? So I'm going to say 5 minus my fraction of 79 over 16. And I get a positive number, so that is okay. Okay, so fractions sometimes can give you positive results, sometimes will give you negative results. So you just got to make sure you check and see. Use a calculator, let it be your friend. Yes, that's a nasty number, but we can work with it with a calculator. A decimal would be okay, as long as it's this correct amount. Is everybody kind of okay with that one? All right. Uh-oh. Got 2 tricks on this one. First of all, we got some logs that we have to combine. Second of all, what kind of logs are they? Natural logs, which means my base is E. So the first thing I would like for you to do is combine the 2 natural logs. We're using the same properties we used with regular logs yesterday. If I have 2 logs that are being subtracted, I can write them as 1 by dividing. So what we're going to do is we're going to say the natural log of x squared divided by 16 equals 0. Same rules for regular logs as with natural logs. Then, because we have a log equal to a number, we're still following these steps. We simplified the one side that needed to be simplified. The next thing we want to do is take it to exponential. But remember, it's E as our base. So it's going to be E to the 0 power equals that fraction. What is E to the 0 power? 1. Okay, so let's change that. Now we have to think about how can we solve this for x. First of all, I need to get rid of the fraction. How can I do that? Multiply both sides by 16. Yep. So that's going to cancel those here. 16 times 1 is 16. That leaves me with x squared. How do I solve for x now? Take the square root. Now remember, when we take the square root, what do we put in front? Plus or minus. The square root of 16 is 4. A positive 4 and a negative 4 is what I have as an option for an answer. But remember, our argument can't be negative. That doesn't mean negative 4 can't work. What that means is we need to go back to our question. Look at the part where my x is. If I were to plug in a negative 4 and square it, would that stay negative or turn positive? It turns positive. So is negative 4 going to be okay for an answer as well? Yes. Okay, so you would have to include both of those here. Does that make a little bit of sense? Everybody okay so far? All right. Now let's change it up a bit. If you'll take a minute and write those down, and then we'll talk about how to deal with these. These, I think, are actually sometimes easier than the others. on this one, what do I have on both sides of my equal sign? I have logs, okay? So we have to solve this just a little differently. However, the first step is still going to be the same as the first step here. I need to get it down to one log on the left side and one log on the right side. So I am going to simplify both sides again. By combining my logs, okay, which is exactly what we've done before. So on the left side, if I have the log base 5 of 4 plus the log base 5 of x, how can I bring those two together? If two logs are being added, I bring them together by multiplying the arguments, okay? So that's going to turn into the log base 5 of 4x. What about on the left side? Do I have multiple logs there that I need to put together? No, it's just the one log. Okay. So I'm going to bring that down. Do you notice how everything is exactly the same on both sides with the exception of the argument? Okay. So remember when we had our variable in the exponent, we wrote the same bases, then we just dropped the bases? Similar things here. We're going to take and we're going to drop the entire log and we're just going to set our arguments equal. Okay, so I'm dropping the log and the base, and because the log base 5 of 4x equals the log base 5 of 36, I can just drop the logs and set the arguments equal. And that is our next step. Once you do that, you solve for x. And then again, just check to make sure that when you plug that answer back into the original question, your argument doesn't turn negative. If I divide both sides by 4, what would x be? 9. If I were to plug that 9 back into the variable here, is that going to be an okay? Is my argument still positive? Yeah. Okay, try 6. Again, combine your logs together on both sides of the equation. Once you get a log equal to a log, you drop the logs, set the arguments equal, and solve for x. We just have to make sure that whatever answers we get will not result in a negative argument. But yesterday when we had to also how do I bring the two logs together that are on the left if they're being subtracted? Division. Okay, so we're going to go the log base 3 of 56 divided by 8. Now, can I do 56 divided by 8? Yeah, what does that give me? So, okay. Now I have one log equal to one log, so I can drop the logs. I set the arguments equal, and then there's nothing to solve for, right? Is 7 going to be an okay answer? Yes, it's positive, so therefore my argument's not going to change. Make a little bit of sense? Kind of, sort of. All right, let me look and see what I got. I got some that we need to get to. I just don't. Ooh. All right. We're going to do this one. solving is we've got to look at, first of all, what situation do we have? Do we have logs equal to numbers or logs equal to logs? Now, when I combine my logs to simplify both sides, first of all, on the right side of this, left side of this equation, is there anything I need to combine? No, it's just one log, so that one's going to stay the same. On the right side, before I combine those, what has to go away first? The numbers in front. They have to go as exponents, okay? So we're going to take the 1/3 and move it as an exponent on the 64. And then we're going to take the 1/2 and move it as an exponent on the 121. And then before I can bring those together, I actually need to figure out what those numbers are. Excuse me. What is 64 to the 1/3 power? Cube root? What would the cube root of 64 be? 4, yep. Plus, then I have to do 121 to the 1/2 power, which means I'm going to take the square root. What's the square root of 121? 11. Now you can put those two together. They are being added. So we will bring them together by multiplying. So that gives me log base 4 of 4 times 11 is 44. And now I have one single log equal to one single log. So I drop the logs, set the arguments equal, and what is it that x is going to be here? 44. So far, so good. Okay. Are we ready for 8? This will probably be the last one we get to today. Remember, either situation, whether it's logs equal to numbers or logs equal to logs, the very first thing we're going to do is bring multiple logs together. So I have the log base 4 of x minus 1 plus the log base 4 of x minus 1. And that's what we did, is we did figure out what the support of the log base 4. 121 to the left is flat. Yes. Okay, how do I move, or how do I get the two logs together that are on the left side? Multiply. So this is what this one's going to look like. It's log base 4. I have to multiply this argument times this argument. So I'm going to show you every single step. I'm just going to write them next to each other first. Now, if I have a binomial times a binomial, we have to distribute or FOIL or whatever you want to call it. I'm going to come over here to the side to do that. Okay, so I'm going to do x minus 1 times x minus 1 on the side. X times x is x squared. X times negative 1 is negative x. Negative 1 times x is negative x. And negative 1 times negative 1 is positive 1. And then if I combine my like terms, what's negative x and negative x give me? So the result of multiplying those, I'm going to put it in parentheses since it's more than one term, is x squared minus 2x plus 1. And then I'm bringing everything else down. I'm going to pause and make sure everybody's good with that. Okay, we have to bring them together by multiplying. We actually had to distribute. Now we're ready. Do I have a log equal to a number or a log equal to a log? Log equal to a number. So we have to take it to exponential next. Starting with your base, 4 to the second power equals that entire argument. Took it from log form to exponential, the little e trick. Starting with your base to the power that's on the right side equals the argument. What is 4 squared? Okay. How do you think I'm going to have to finish solving this thing? We're going to have to factor. And if we factor, we have to get it equal to 0. So let's start by moving our 16 over. I subtracted over my 16. That gave me x squared minus 2x minus 15. What I need you to do is I need you to finish solving that. Factor that for me. You're looking for numbers that multiply to give you 15 and subtract to give you 2. Multiply to give you 16 and subtract to give you 2. What are those numbers? 5 and 3. Are my signs going to be the same or different? Different, and the first one goes in front of the bigger number, so it is going to be a minus 5 and a plus 3. And then remember, we set each one of those equal to 0. I'm going to come over here because I'm running out of room. And I solve individually. So I have 2 possible answers. They can both work. One of them can work or none of them can work. And what I mean by that is we have to go back to the original equation before I did anything else and plug in each number. Okay, so our options are negative 3 and positive 5. So let's look right here in the yellow highlighted portion. If I plug in a negative 3 there, is that going to give me a positive number or a negative number? Negative, okay. I can't have a negative argument, so negative 3 cannot be an answer. And then if I plugged in 5, does 5 minus 1 give me a positive number? 5 minus 1, yeah. So 5 can work. Now, not every negative number is going to be a toss. Sometimes they work like that negative 4 that we got earlier. So you just have to go back to the original question, plug it in. If the argument turns negative, that answer has to be thrown away. Does that make a little bit of sense? Anybody have any questions? All right, we're doing this. I think we're doing this again tomorrow. I have to look at my plans.